Imagine a power grid that doesn't just deliver electricity, but thinks. It senses demand spikes, reroutes flows across continents, anticipates equipment failure before a breaker trips, and seamlessly integrates renewables, storage, and electric vehicle loads into one resilient system. This is no longer science fiction. It's the new reality at the intersection of artificial intelligence and energy infrastructure. Welcome to the Tech Radar. Today, we're diving into how AI is transforming the energy industry. From generation to transmission to consumption, from fossil fuels to renewables, from smart grids to digital twins. We'll explore in rich detail how this works, how much is being invested, the challenges ahead, and what this means for economies, companies, and you. Let's start by setting the scene. The energy industry is undergoing its most profound transformation since the shift from coal to oil a century ago. Carbon constraints, distributed generation, electrification of everything, grid instability, aging infrastructure, these forces are converging. Layered on top of that is artificial intelligence taking off with the capacity to digest petabytes of sensor data, satellite imagery, IoT streams, grid logs, and weather forecasts. According to a systematic review, recent advances in transformer architecture and large language models are now beginning to augment decision-making not only in high-level planning, but also in day-to-day operations, from forecasting and grid balancing to workforce training and asset onboarding. One executive captured the urgency. "There's no way to get there without a breakthrough," said Sam Altman, CEO of OpenAI at Davos 2024, adding that future AI demands hinge on energy breakthroughs. Reuters. The energy industry is thus both provider and beneficiary of AI evolution. As Sultan Al Jaber, CEO of Abu Dhabi National Oil Company, ADNOC, put it, "By integrating AI and energy, we can unlock economic and social value." So how exactly is AI being used in energy? We'll walk through key domains: forecasting and load management, asset performance and predictive maintenance, renewable integration and storage optimization, demand, side flexibility and consumer engagement, and finally the emerging frontier of digital twins and agentic energy systems. Each domain involves unique data, algorithms, deployment challenges, and value creation. At the heart of energy operations is prediction. How much electricity will be needed, when, where, and for how long. Traditional models were linear, rule-based, and used a few variables: weather, historical load, scheduled outages. AI changes the game. Machine learning models ingest thousands of features: grid sensor data, weather forecasts, satellite cloud cover, building occupancy, EV charging patterns, and deliver forecasts with 10 to 20% improved accuracy and up to 24-hour, 48-hour horizon improvements. For instance, a paper on the powerful use of AI in the energy sector, intelligent forecasting, describes how supervised learning models fused with physics-based understanding reduce dimensionality and increase confidence. As reserves shrink and grids incorporate intermittent renewables, that extra accuracy translates into millions of dollars saved in fuel, ramping costs, and reliability reserves. One major utility reported an AI forecasting system reduced error in day-ahead load forecasting by 115% and cut reserve margins by 3 percentage points, saving roughly $10 million in a single year for a regional grid. These figures scale globally. Global investment in AI for energy is expected to grow at a compound annual growth rate, CAGR, of 33% to reach more than $15 billion by 2030. With generation, transmission, distribution, and retail segments each leveraging AI, the economic stakes are enormous. Power plants, wind turbines, solar farms, substations, all are capital-intensive assets that must run reliably. Unplanned downtime is expensive, in the range of hundreds of thousands to millions of dollars per hour for a utility. Enter AI. Condition monitoring sensors capture vibration, temperature, oil analysis, acoustic signals, and capture anomalies. Machine learning models detect subtle precursors to failure: bearing wear, insulation breakdown, rotor imbalance. When AI triggers maintenance before a failure, uptime improves 5–10%. Maintenance costs fall by 20–30%, and asset life extends. A review on AI governance in smart energy systems emphasizes this trend and also the critical need for explainability, because grid operators cannot run black boxes when lives and reliability are involved. For example, wind operator Vestas reported that AI-driven maintenance reduced turbine failure by 21% across its global fleet within 18 months. Renewables bring variability. Solar drops at dusk, wind shifts unpredictably, storage is expensive. AI plays several roles: forecasting renewable generation, optimizing battery dispatch, coordinating hybrid systems, solar plus wind plus storage plus grid, arbitraging electricity markets, reducing curtailment. For instance, AI can predict solar output not just by weather, but by cloud movement via satellite imagery, match it with battery charge/discharge, and thereby reduce curtailment losses by up to 25%. A whiteboard paper discusses how DERs, distributed energy resources, can be integrated into an Internet of Energy managed by AI, but warns of equity issues if certain prosumers dominate. In one project, a large solar plus storage microgrid reduced levelized cost of storage, LCOS, by 8% using AI optimization, improving project economics from use $200 to use $193. Traditionally, utilities shifted supply to meet demand. Now, demand flexibility means shifting consumption to match supply. AI enables this by analyzing consumer behavior, appliance usage, EV charging, thermostat adjustments, and orchestrating demand response in real time. Smart meters send minute-by-minute data. AI models cluster behavior, send prompts, or program thermostats. One study simulated peer-to-peer electricity trading using AI in a prosumer market, where households with PV, storage, and EVs trade among themselves. This shift promises to reduce peak loads by 10–15%, cut costs for consumers, and defer grid upgrades. But the challenge: data privacy, regulatory frameworks, and algorithms making thousands of autonomous small decisions rather than central planning. We are entering an era of digital twins, virtual replicas of physical assets or grids that simulate real operations, test scenarios, and predict outcomes. AI models enhance these twins with autonomous agents. A recent review puts it this way: large language models and transformers are now being adapted for energy sector tasks. We introduce the concept of the agentic digital twin, a next-generation model that integrates LLMs to bring autonomy, proactivity, and social interaction into digital twin-based energy management systems. Predictive. In practice, an oil company announced such a deployment. It will speed up seismic surveys from months to days. It will increase the accuracy of production forecasts by up to 90%, said Sultan Al-Jaber. These systems monitor grid health, forecast maintenance, orchestrate storage and renewable flows, and interact with human operators in natural language. The implications: faster response, lower risk, more resilient grids. Let's add the numbers. According to multiple sources, AI in energy investments by major oil energy companies are approaching tens of billions. For example, ADNOC allocated $23 billion to develop low-carbon technology using AI, targeting a 25% reduction in emissions per barrel by 2030. From another angle, AI data centers driving this demand could consume 20–25% of U.S. power by the end of the decade, up from 4% today. This implies the energy industry must adopt AI to manage both consumption and production at scale. The smart grid market alone is projected to grow from around US $27 billion in 2023 to over US $50 billion by 2030. But this transformation is not without obstacles. First, explainability and trust. AI decisions in energy may affect physical infrastructure, safety, and lives. A review of AI governance in smart energy systems found that explainability is fragmented and immature. Second, data quality and integration. Energy systems generate petabytes of heterogeneous data, sensors, satellite, logs, customer usage, but cleaning and integrating it remains difficult. Third, cybersecurity and physical risk. An algorithm controlling grid flows becomes a target. Fourth, regulatory and market risk. For example, the UK energy regulator warned of AI collusion in energy markets, where algorithms might implicitly coordinate pricing without human oversight. Fifth, equity and inclusivity. The Internet of Energy vision risks favoring those with resources to supply and trade power unless frameworks ensure broader participation. Without proper governance, AI could exacerbate inequality or create new systemic risks. Bringing all of this together, AI in the energy industry is not a side improvement. It's a foundational shift. The grid becomes intelligent, flexible, self-diagnosing, and dynamic. Generation, storage, transmission, and consumption will be orchestrated by algorithms. The winners will be those companies and utilities that adopt AI early, build data-driven cultures, secure ecosystems, and maintain ethical governance. For countries, harnessing AI means meeting rising demand, integrating renewables at scale, reducing carbon, and enabling electrification of transport and industry. As Sultan Al-Jaber put it, the size of this opportunity only became very apparent about 18 months ago when ChatGPT took off. For you as a professional, student, investor, or citizen, this means the cost of electricity, the reliability of your home power, the behavior of your car charging, and the carbon footprint of your tech are all about to change, with intelligence behind the scenes. As the energy world gets smarter, you've got a front-row seat to one of the most consequential shifts of our time. If you found this deep dive into AI and energy insightful, please like this video, comment below. Which area of energy AI interests you most, and which worries you? And if you haven't yet, please subscribe to the Tech Radar for weekly explorations into AI, tech, and our future. Thanks for watching. I'll see you in the next video.